So in this question here, we've got a pentagon, and this pentagon has to have perimeter of 100 meters. And with that pentagon having 100 meters perimeter, we want to find out what's the maximum area we could have with that condition there. That's the only condition. So how are we going to work that out? Well, I'm going to do this calculation using calculus. So with a pentagon here of this shape, the top bit there, I'm going to use an equilateral triangle because that has the greatest area of all the triangles in terms of the relationship to its perimeter. So if I just draw a line across there, and I'm going to label my two lines of the triangle there, the two hypotenuses, if you want to call that, X. So if I go a line down here, with it being an equilateral triangle, that vertical height there of those triangles give me two hypotenuses of equal distance. And then what I'm going to do is I'm going to call my baseline of this triangle also X, which will also correspond to here. And then I'm going to need to variate the heights of these sides here accordingly. So I'm just going to give them a variable K. So basically this K value is going to change up or down accordingly, keeping a perimeter of 100 meters, and these X's will change accordingly as well, but still keeping 100 centimeters. So let's set up our formulas and our conditions for that. So first of all, we know the perimeter is 100 meters. That will equal 3x plus 2k, and that's going to equal 100. So I'm not worried about meters at this stage. Then I need to work out what's my formula for my area. So the rectangle, straightforward here, I've got x and k. So my area of the rectangle, let's just do a little symbol there just to show what we're doing. I've got x times k. Now what about my triangle on the top? So if I just draw a little line here just to try and represent that. So these will be right angles. This will be my vertical height. Now I know these sides are x. I'm just going to concentrate on this one for now. So my base, this part will be x over 2 as the whole base is x. Then I need to calculate what my vertical height is to calculate my area. Well, as it's an equilateral triangle, I'm going to have an angle here of 60 degrees. So then if I've got this, I can find this, because then I can do tangent is opposite over adjacent. So I'm going to call my my opposite side, h, that's my height. So then I will have tan 60 degrees equals h over x over 2. Then, well, tangent 60, we know that is square root of 3. So then I will have my h equals root 3 x over 2. So that's my height. So then I can calculate the area of this whole triangle because I've got my height and I've got my base. So then I'll have my area of my triangle. So base times height over 2. So I'll have 1/2 times x times root 3 over 2x. So that will now simplify off a little bit. I will now have root 3 over 4 and then x squared. That's for my triangle. So now my total area, if I just call that just A on its own, I'll have this plus this. So that's xk plus root 3 over 4 x squared. Okay, now to maximise this, if I consider it like a graph, what will happen is I'll have a little graph that looks like this, and along this line here I'll have my x value, and here I will have, instead of a y value, I'll have my area value. And if x is 0, obviously there's no area, and that value of the area will go up accordingly as my x increases, and it'll reach a point. We can see here we're going to get a quadratic. It'll reach a point and it will roll back down symmetrically, and that will be the point there where it also has no height. So these 2 points will have no height. But here, where the curve changes direction, that's going to be the point where my maximum area is. So I need this x value here. So that will also give us my area according to what my x value is. So what we're going to do now, well, we've got area is xk plus root 3 over 4 x squared. Now the k there is just getting in the way a little bit. So let's isolate the k from here and substitute it into that. So I've got 3x plus 2k equals 100, in which case k will equal, well, 100 minus 3x and then divided by 2. So I'll have 50 minus 3 over 2x. So that'll be my k, and let's substitute that in there. So then my area, with just x values, that's going to help us to find this point here. I'm going to have x times k, which is 50 minus 3 over 2x, and then plus my root 3 4x squared. Okay, right, let's just do some simplifications on this. So now I've got 50x minus 3 over 2x squared plus root 3 over 4x squared. Okay, well I've got two x squared terms, so let's just combine those. Then I'll have my area will be root 3 over 4. Let's just put that in a bracket. Root 3 over 4 minus 3 over 2. And then x squared. And then I'm going to have plus 50x. Okay, now we need to find this turning point. So that'll be found when dA dx, our derivative with respect to a, is 0. So let's take the derivative of this. So my dA dx, well, derivative of that, well, this is just a constant, so we don't need to do anything with that. Derivative of that is 2x, so times all this by 2. So then I'm going to have root 3 over 2 minus 3, and then my x, that's all multiplied by 2, and this will just be plus 50. And then that equals 0. Okay, well, what we can do now is we can just isolate the x, and we've got our x value for there. So what have we got now? So x will be that, bring the 50 over this side, and then divide everything by this. So x will equal minus 50 over this, root 3 over 2 minus 3. Now we'll see here that this is a negative, this is a negative. So what I can do is switch these around, and that will then bring this into a positive. So x equals minus 50 divided by 3 minus root 3 over 2. And then with that, because that's switched, I can also get rid of this minus sign. So then that will be gone. So that's my x value. Okay. So what does that tell us so far? Well, it tells me the x I can plug into here to give me my maximum area. But I want this area here, xk plus root 3 over 4 x squared. So I still need to find what k is. Well, if I know what x is, I can plug it into here and solve for k. So I got my k from that. 50 minus 3 over 2 times this. So I've got 50 divided by 3 minus root 3 over 2. So times all that by 3 over 2. So now k will equal 50 minus, well, 3 times 50 is 150, divided by 2 is 75. And then divide that by 3 minus root 3 over 2. Okay, well, we can plug this into our calculator and we will get k equals 14.85. Now that's approximately, plugging into calculator to get a lot of decimal places, but that'd be close enough for now. And then we've got our x here. X is also approximately 23.43. Now if we just check what we got there, 3 of those plus 2 of those should be around about 100, and if you do the detail on that, that works good. So I'm quite happy with my X and my K. So all I need to do now is work out what my maximum area is. So where's my formula there? I've got area equals xk. So this will be maximum area. That's going to equal x, which is 23.43, times k, which is 14.85. And then we can add root 3 over 4 times x squared, 23.43 squared. Okay, maximum area equals 585.7, and that'd be meters squared. So with that, so that'd be my maximum area, 585.7 meters squared, with a perimeter of 100 meters. And with that, we could find a general formula for the maximum area with any perimeter. So what we could do is, if we set perimeter equals 3x plus 2k in this format, what I can do is then my maximum area will be using this formula. So my area would equal xk plus root 3 over 4x squared. That's going to work for any perimeter of a pentagon. Now if it's 3x plus 2k equals p, the bit I need to do now is just adjust this bit here, in which case k would equal, I've now got 50, which is my, in this case, is my perimeter over 2 by virtue of the 2k. So then k would have to equal p over 2 minus 3 over 2 x. And with those conditions there, you can maximize the area of any pentagon. Okay.